Good morning. Today we are starting our last unit. Woo. It is already that time of year that we are on the last unit. So we are going to be working with probability for this unit. There are only 4 objectives. So we have Monday, Tuesday, Wednesday, Thursday of this week, which means we'll be testing next week. Practice test will be on Tuesday, real test on Wednesday of next week. We only have so many days to get retakes done. Right, so we have a retake day this Friday, retake day next week Friday. If you have a lot of power objectives that you need to retake, more than 1 or 2, we're gonna want to get those done after school Wednesday and Thursday of this week. So really think about how many objectives you have to retake. I'm still working on correcting the ones from Friday, so I will get those hopefully out and ready for us by tomorrow. So you'll know if you should stay after Wednesday or Thursday to try to get on top of those. So today we are starting with CO72. I can determine the number of possible outcomes of an event. So we're gonna, first thing is to know what possible outcomes means. Possible outcomes is a list of all the resulting possibilities from an event. So we're going to look at each thing that we do is an event. Flipping a coin. Every time you flip the coin, it is an event. Rolling a dice. Every time you roll the dice, it is an event. Spinning a spinner. Every time you spin the spinner, that is an event. Okay. So we're going to look at what are possible outcomes we could have all together. So there are 2 different ways we can do this. The first way is using a probability tree. We're going to look at probability trees and then we'll go back and look at the counting principle. So flipping a coin 3 times. Let's look at how we make a probability tree for that. So how many events are happening if we're flipping that coin 3 times? How many events would that be, Kylie? 3. So we're going to have flip 1, flip 2, and flip 3. Because there are 3 events happening. Every time we flip, it's an event. So we're starting here with our coin. We flip it our first time. What outcomes could we get flipping that coin? What are our possible outcomes? Bennett? Heads or tails. So we could get a heads or we could get a tails. So for flip 1, that's our possible event or outcome. Now we're going to flip a second time. So let's say the first time we flipped the coin, we got a heads. So we're going to go up here to our heads. What choices possible outcomes do we have for flip 2? Liam?
2 heads and tails.
We flipped it heads the first time. The second time we flip it, what could it land on?
Head.
Or?
Tail.
Yeah. So we have the same outcomes could happen, heads or tails. Let's say the first time we flipped our coin, we had a tail. What possible outcomes could we get for our second flip? Emma?
Heads or tails.
Heads or tails. Now we're going to flip our coin a third time. Let's say the first 2 flips we got heads. What possible outcomes could we get for our third flip? Adeline? Heads or tails? What possible outcome could we get if we flipped a heads? Then we flip to tails. What could we get for our third flip? James?
Heads.
Or?
Tails.
Now, let's say the first time we flipped it, we got a tails. Then the second time we flipped it, we got a heads. What could we get for our third flip? Liam?
Heads.
Or?
Tails.
How about if we flipped to tails, and then we flipped to tails? What could we get for our third flip? Maddie?
Heads or tails.
Heads or tails? So, we have a list of outcomes that we can make. What are the possible outcomes? We could get heads, 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 right across the top. We could get heads, heads, tails. We could get heads, tails, heads. We could get heads, tails, tails. Then we could get tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. So those are all the possible outcomes we could get. All right, all the different combinations we can have. How many possible outcomes are there if we flip a coin 3 times? Maddie? 8. We count them up. 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Now let's look at our second question. You have 3 pairs of pants and 4 shirts. How many possible outcomes can you make? How many possible outfits can you make? So how many events would we have in this situation? Bridget?
7.
No. We're not going to just add them together because pants and shirts are different. So we're going to choose what pants we're going to wear. We're going to choose what shirt we're going to wear. How many events are we choosing from? Adeline? 2. We have pants as one event. What pants are we going to choose? And then we have shirts as another event. What shirts will we choose? I'm going to give myself a little bit more space here. So, how many different colored pants could we have to choose from? Kylie? 3. So who can tell me a pants color? Bridget?
Blue.
Blue. What's another pants color? Liam?
Red.
And what's another pants color? Sophie? Black. So, for my pants, I could have blue, red, or black. So I'm going to make 1, 2, or 3 choices there. What color shirts could I have? Adeline?
Yellow.
Yellow. What's another color shirt I can have? Sarah? Periwinkle. What's another color shirt? Etta? Pink. And what's a 4th color shirt? Sophie? Purple. Lots of P's there. All right. So if I chose blue pants, what shirt combinations could I choose? James?
Yellow.
Periwinkle,
Periwinkle. And pink. And purple.
I could choose all 4 of those color shirts. What if I chose red pants? What could I choose? Emma?
All four.
All 4 again. Even though it might not be the prettiest outfit, the most put together outfit, I could still choose all 4 of those. So I could choose, I'm just gonna write a yellow, a PE for periwinkle, a PI for pink, and a PU for purple. What if I chose black pants? Emma?
Could it be all?
Yeah, I could choose all 4 again. So I could have yellow, periwinkle, pink, and purple. So, what are my possible outcomes that I could have? We're just gonna go across like we did with our heads and tails. So, for the heads and tails, we had 3 flips, so there were 3 letters in our possible outcomes. But with the pants and the shirts, there are only 2 events happening. So we're gonna combine it with 2 colors, our pants and our shirts. So we could do blue and yellow, blue and periwinkle, blue and pink, blue and purple. Then we could do red with yellow, red with periwinkle, red with pink, red with purple. Then we've got our black pants. So we would have black with yellow, black with periwinkle, black with pink, and black with purple. How many outcomes do we have for our outfit choices? So we've got the 4 blues, the 4 reds, and the 4 black combinations. How many is that, Lila?
12.
There are 12 different outfit combinations we could make. Now, we would want to use the probability tree when we want to see those specific combinations. How many blue choices are there? How many outfits would have pink in them? We can see all of those different outcome choices. But a lot of times, the questions will be, how many outfits can you make all together? We don't need to know them broken down. How many outcomes would there be flipping that coin? We don't need to know how many heads, how many tails. We just want to know the total number of outcomes. So if we just want to know the total number of outcomes, we can use the counting principle. The counting principle, we still have flip 1, flip 2, and flip 3, because there are 3 events happening. So we have to make sure that we put every event on top. This is the most common mistake people make. They don't put all of the events for the counting principle. So always, always, always ask yourself, how many events are happening? How many choices are you making? And then make sure you have each event in that counting principle. So we've got our events happening up top, and then on the left we say the number of outcomes for each event. So we're going to look at each event, we're going to look at how many outcomes there are all together. So, you missed this part to here for theology. And then get out your math finder. Okay, so flip 1, how many outcomes are there? James? 2. You could get heads or you could get tails. So we put a 2 there. Flip 2. I flip my coin a second time. How many outcomes are there with that one flip of the coin? James, or Bennett?
1 or 2?
Which one do you think it is?
2.
Why 2?
Because there are only 2 sides.
There are 2 sides to the coin. I could get heads or tails. Flip 3. How many outcomes are there that I could get? Lila? 2. Heads or tails. Now comes the mathy part. To figure out how many outcomes there are all together, I'm going to multiply each of our individual outcomes. What is 2 times 2 times 2? Well, 2 times 2 would be 4. 4 times 2 is, Kylie? 8. Look at that. I don't have to go through that whole probability tree if I don't need to know every single event, what would be in each one. How many times can you get tails and heads and tails? 2 tails and 1 head. I would need to do the probability tree to figure that out. How many outcomes are there when you flip a coin 3 times? I can just do that counting principle. So let's look at our outfit choices. How would I set up my counting principle for my outfit choices? What are my events? What do you think the events are? Oh, only a couple of us know. What would the events be? Sophie? Pants and shirts. Right? Those are the things that we are making choices on. Our pants and our shirts. Pants, shirts. Up here we had 3 events with 3 flips. Down here we are choosing what color pants, what color shirts. So then remember, this is number of outcomes. How many outcomes are there for pants? How many choices can I make when it comes to the color of pants? Emma?
3.
3. There are 3 colors of pants, so there are 3 outcomes for the pants. How many outcomes are there for the shirts, Sarah? Say it louder. 4. There are 4 colors of shirts, so there are 4 outcomes for shirts. Am I done? Does that tell me how many outfits I get? What do I have to do? What math do I need to do with my 2 outcomes that I have there? Sarah? I need to multiply them. So notice how I'm putting that multiplication symbol on the line, so I remember I'm going to multiply them. So I actually want you to put that multiplication symbol there so you remember what math you're doing. What is 3 times 4? Kylie? 12. Look at that. 12 outfit choices and 12 outfit choices. Both ways we get the same answer. There are 12 outfits that we can make with 3 pants and 4 shirts. The counting principle gets us there a whole lot faster when we just want to know the total number of outcomes. How are we feeling about the counting principle? Show me your thumbs. How are we feeling about the probability tree? Okay, probability tree, some of us are like, I'm kind of there. We just have to remember we write everything out with that probability tree. With the counting principle, we just have to put the numbers in there. So the probability tree is just actually writing it out. If I flipped a heads, then what can I flip for my second flip? If I flipped a tails, what can I flip for that second flip? Did you get it all there? Which one do you need? Down here? You know what, Kellen? Let's give you this. It'll help. So you don't have to write all of the notes out, just fill in the parts that are missing. Yep. And I'll do that for you all week. So as I'm writing stuff up on the board, you need to be writing it in your notes. We're gonna do that bottom section together. Kellen, I'll help you with filling in what you missed. I gotta move on now. So let's look at the bottom of our page. It says, using either method, determine the possible number of outcomes. Show your work. So I'm going to tell you right now, what do you think my favorite method is to use? Any guesses? What do you think my favorite is? Lila,
Counting principle,
why the counting principle?
because it's faster.
Because it's faster. You don't have to do as much work. You get the same answer with less work. So I like to do the less work method. So let's practice. We're going to practice using that counting principle. If there's anybody who wants to use that probability tree, when we get to work time, I can work it through with you with the probability tree. But let's look at that counting principle.
Hi, quick thing, did anybody leave a twins hat at the dance on Friday? Twins hat? No? Okay.
Oh, thank you. Okay, so when I do that counting principle, what do I want to put up top? Emma.
Flip one, flip two, and roll.
So I'm going to put all of the events. You flip a coin twice. So Emma's right. I have flipped one, and I have flipped two, because I flip a coin 2 times. Then it says, then you roll a dice. So then I have a roll. So I have 3 events happening. I flip a coin, I flip a coin, and I roll my 6-sided dice. So remember, on the side here is number of outcomes. So I look at flip 1, how many outcomes do I have for flip 1? Aaron. If I flip a coin, how many possible outcomes could there be? 2, heads or tails. What about for flip 2? How many outcomes could I have? Charlie. 2. I roll my 6-sided dice. How many possible outcomes could it land on? Jack. If I roll a 6-sided dice, a regular dice, how many different numbers could it land on? 6, right? Because there's 6 numbers on my dice. It could land on any of those 6 numbers. What do I do next? Sophie. I multiply all of my outcomes together. It doesn't matter if I only had 2 events or if I had 5 events. It doesn't matter the number of events. You fill out your table and you multiply all the events together. So we have 2 times 2 times 6. How many possible outcomes are there? Aiden. 24. 2 times 2 is 4. 4 times 6 gets me to that 24. My question was, how many possible outcomes are there? There are 24 possible outcomes. If we wanted to see all of those possible outcomes, we would do the probability tree. So we could see heads, heads 1, heads, heads 2, heads, heads 3, heads, heads 4, heads, heads 5, heads, heads 6, right? You could see all the different combinations that you can get. And you'd be able to list all 24 of them. So How are we feeling about that now? Let's look at our homework page. Using either method, if you want to use the probability tree, totally fine. If you want to use the counting principle, totally fine. Either way, you have to show your work. Show all of the steps that you're doing, all of those outcomes, whatever you're doing. So, a pizzeria has 4 types of crust, 15 toppings, and 5 pizza sizes. How many one-topping pizzas can be ordered? Well, how many events are happening? That's the first thing we ask ourselves. What are the events happening? Kylie?
4 types of crust,
Mm-hmm.
15 toppings, and 5 pizzas.
Yeah, we've got 3 different choices to make. Each choice is an event. So there are 3 events. We've got types of crust, we've got 15 toppings, and we've got 5 pizza sizes. Which way do you want me to work it out? Probability tree or counting principle? Lila. All right, let's work it out using that counting principle. How should I label my table? Because we always need to label our table to make sure we have all events covered. What should I put in my labels? Kylie?
Crust, toppings, pizzas.
Crust, toppings, and sizes. Remember, on the left, we have number of outcomes. So I look at that and I say, how many outcomes could I have for the crust? Natalie? 4, because there are 4 types of crust, so I'm going to put a 4 in there. How many topping outcomes are there, Liam? 15. We have 15 toppings here, so I put a 15 in there. How many sizes? Lexi?
5.
5. There are 5 pizza sizes. What do I do now? James? Multiply them all together. So I'm going to put that multiplication symbol in there, showing what math I'm doing. What is 4 times 15 times 5? Sarah?
300.
So I have 4 times 15 times 5 equals 300 different one-topping pizzas that we could order. Whew, that's a lot of different choices for our pizzas. James?
I'm kind of glad we didn't do like the top
The probability tree would have taken a long time. That's why the counting principle, when you just need to know the total amount, counting principle is a whole lot easier, because James is right, 300 different options would be a lot. You're going to work on the rest of this page on your own. Always ask yourself first, what are my events? Then set up your table with each of those events, and then you put the number of outcomes for each event. So first, figure out your events. Second is fill in your table. Third step, multiply across. So make sure you do all 3 steps. So I'm not going to do the whole problem with you. Who can tell me how many events we have with our truck design? How many events would there be looking at that table? Sarah? Say it louder. 4. Cab size, wheel cover, spoiler, and paint color. So in your table, you should have all 4 events. And then how many outcomes for each event? And then you multiply it across. If you are working on this at home, I hope you come to me if you have any questions. Please remember, working on those practice works and retakes, checking to see should I stay after school Wednesday or Thursday of this week to get retakes done. All power objectives and Math 6 review objectives, they all need to be passed to move on to pre-algebra next year. So we need to be working on those. If you are at home, I hope you are well, and I hope to see you soon. Have a wonderful day.